Example 2 and 1.2 is a really fun question. Maybe you're not going to agree with me, but that's okay. And it gives us some information. It says that the sum of the first two terms is 13, and the sum of the first four terms is 46. Then what it wants to know is it wants to know term 1 through 6, and it wants to know the sum of those 6 terms. So the way that you start, and I would always recommend starting this way, is make sure you have a formula sheet, you printed it, or you can look at it digitally, and then take a look at what formulas you have for the sum of n terms. Now, we haven't done them yet, but in 1.3 and 1.4, we're going to talk about geometric sequences and series, so you have to know which we use for arithmetic and which we don't. And most students will immediately jump, and I'll put them up here, to this formula. It looks a little bit easier. And it seems like it's going to be a better choice. And if I use that formula, I could say that the sum of the first two terms is equal to, we know n is 2, so it's 2 over 2, but I don't know term 1, and for this particular equation, I don't know term 2. So we run into a bit of a, maybe not a brick wall, but we get that 13 is equal to term 1 plus term 2. That's not bad, right? If we can get another equation with term 1 and term 2 in it, then I have a systems of equations. But we run into a bit of a snag, because when I say that the sum of 4 terms is 4 over 2 times term 1 plus term 4, I get that 46. Oops, let me write that a little bit better. 46 is equal to 2 times term 1 plus term 4. And a lot of students will think, well, I'm in business. Those were TN, but they're not. We're talking about the sum of 4 terms and the sum of 2 terms. So term 2 and term 4 are not the same. And so what we end up with is a systems of equations that has 3 variables with 2 equations. We can't solve that. Now, but before you think I'm incompetent, I wanted to show you what typically students will try. We are going to use the better technique, which is to understand that there is another formula. And the advantage to this other formula is that for both of these equations, we knew n and we knew Sn, which means if I look at that formula, knowing what n is and knowing what Sn is, the only remaining variables are going to have to be the term 1 and the common difference. So if I can get 2 equations in terms of the common difference, then we're actually going to get a systems of equations. I'm going to do that up here. I'm going to say that the sum of 2 terms, which is 13, is equal to, so that's still going to be 2 over 2. But now in the bracket, I'm going to have 2 times whatever term 1 is, plus 2 minus 1 times the common difference. Now again, I'm going to clean that up a little bit. I get that 13 is equal to 2 times term 1 plus d. So again, an equation with 2 variables. The advantage to what I'm doing here is that when I use the sum of 4 terms, I can say that 46 is equal to 4 over 2 times 2 times term 1 plus 4 minus 1 times the common difference. So I clean that up a little bit. I get that 46 is equal to 2 times 2 times term 1 plus 3 common differences. And to make this as simple as possible, I'm going to divide both sides by 2. So now I also have that 23 is equal to 2 times term 1 plus 3 common differences. And the reason why that's so powerful is now I do have 2 equations with the same 2 variables. So what I'm going to do here, and it really depends on what you're comfortable with, whether it's elimination, substitution, it doesn't matter. I am just going to write these in the way that I would solve this, because both of these equations contain 2 term 1, or the term 2 times term 1. What I'm going to do is I'm going to use elimination, right? Because these two, and I'll do a little dotted box around them, are exactly the same. When I subtract those equations, I'm going to eliminate that variable. So 23 minus 10, 23 minus 10, 23 minus 13 is going to be 10. 2 term 1 times 2 term 1 is 0. Let me put a bracket around there. And 3 common differences minus 1 common difference is 2 common differences. Well, when I divide this by 2, I get that 5 is the common difference. That's not enough, though. I need to know what the first term is. So I'm going to go back and I'm going to plug it into this equation. Really doesn't matter which one, but this had a little bit of a simpler coefficient on the d there. When I do that, I get 13 plus, or 13. Geez, not a good example here. Sorry about that. I'm going to get that 13 is equal to 2 times whatever term 1 is plus 5. I'm going to move the 5 over. I get that 8 is equal to 2 times term 1. When I divide by 2, I get that 4 is equal to term 1. Now, knowing the first term and the common difference is enough, because what I can do now is I can start my series. So I'm going to have 4. I'm going to add 5 to that, which gives me 9. I'm going to add 5 to that, which gives me 14, then 19, then 24, then 29. Did I go too far? That's 1, 2, 3, 4, 5, 6. And that's where it's going to end. Now, one of the best parts about this is we can now check our work. I'm going to check these two. The sum of these two numbers, 4 plus 9, is 13. That works with what they told us in the original question. I'm also going to check these four right there. The sum of four terms, and I'll write it here, is going to be 4 plus 9 plus 14 plus 19. 4 plus 9 is 13. 14 plus 19 is 33. And I get 46. Again, that checks out with what the question gave us. The last part of this question then is what is the sum of all 6 of those terms? Now, you could add 6 numbers. That's not ridiculous, but I'm going to go with the Gauss technique, which I'm going to use. The number of terms is 6. I'm going to divide that by 2. I'm going to multiply that by the first term times the last term, or the 6th term, because it's the sum of 6 terms. And I get that the sum of these 6 terms is 3 times 33. So it's 99. Now, if you want to, I suppose you could use your calculator and confirm that by adding all 6 numbers, but we want to focus on the algebraical technique using the formulas that Gauss derived for us.